I guess question, right? But Brian is here.
Yes, I do actually. Spencer did not let me give it back. Yeah. Christian is talking. He said you. And right there. Oh, he is. That's okay. Great. The hat would solve the problem.
Oh, we can start already.
You're allowed to. I was thinking if you were allowed to, you would have done
Did you open all the slides? Or
no, I just opened. So if you hit back, you get back to the session. And you managed to right-click on them. So.
Do we have a note taker? No.
No.
It's all right. Eric is taking notes. Not too many, but we have some open mic time. But nobody will say anything. Okay. We will have we want some feedback on like MPTCP and where to do the work, so that could be some discussion, but I can, when you're using Etherpad, I asked Brian. Okay, I watch Java in here. Okay, should we start? Okay, hello everybody. Welcome to Tsvarea. You made it until Thursday? Yeah. I'm Mia Kulevind.
Magnus Westlund.
And we are your IDs. We have also in this session, we have the note well. You should have seen it already. But maybe you want to reread some parts of it. Maybe you want to look at the code of conduct again. That can be useful from time to time. Keep it in mind. This is our agenda today. We just started. You have a chance to bash the agenda basically right now if you want. We have, as usually, a couple of slides about what we did in the last couple of months and what the working groups are doing right now. Then, like, I have a point where I would like feedback from the community about where in the IETF to do multipass work, because it's coming up in different places. And I want to make sure that people are aware and talk to each other. So maybe you have better ideas than I do. Then we have a talk by Christian about congestion defense in depth. And finally, we get an update from Robin, which is a remote talk. He presented some quick-based logging schemes last time, and he has pushed out 2 drafts and a lot of work. And so we thought we'd give him some time to update on what he did. Any questions about the agenda? As always, we would like to thank our review team. We got quite frequent reviews in the last couple of months, and that's always very helpful. You can see it's not like a huge load, but it's important to have those reviews in quickly, and yeah, some good feedback from these people. Thank you very much. This is also the usual slide, which just like kind of summarizes very briefly our view about the current status of each working group. The one thing to mention is that there's one working group less, but also a big thanks to everybody who worked on this working group and did the work in this group. So we closed it successfully and have the RCs out there now. Anything else you want to mention?
Nope.
No. If there are no questions, I go on. Also, just to be a little bit proud of ourselves, this is like the documents that we published in the last couple of months. A bunch of them are in the editor queue right now, and 4 new RFCs out of transport area. Is that? Oh, there's more stuff coming. Yeah, so just mention stuff that's related to transport.
This is an old slide, isn't it?
Yeah, that's an old slide. I was like, this one. This is the right one. Okay, just to mention stuff that's related to transport. Most of those things had happened already because it's Thursday. The only thing that's still on tomorrow is MapRG, and as usually there are a couple of transport-related discussions there, presentations there. But like you can also go back and watch the recordings. There was ICCRG with some interesting TCP related and congestion control related talks. There was something which does touch transport quite a lot in dispatch. That's called web transports. So if you haven't heard of that yet, maybe have a look at it. And Panergy also didn't happen yet, right? No, it did.
Yes.
Just, yeah, okay. Damn, it's over, sorry. But of course, it's transport related. Sure.
Hi, Brian Trammell. I'll make one point on the web transports thing. They also had a side meeting here, and it seems like the outcome of that side meeting is going to be they're going to think about maybe doing a BOF in Singapore. I don't know what area they're going to send that to, but if it doesn't end up in the transport area, even though it's got transport right in the name, we should make sure that there is encouragement for transport people to show up, because it definitely needs transport eyeballs on it during the BOF phase.
David Skenazy. To add to the web transport topic, we have just created a mailing list, web transport at IETF. It's currently under the applications area. But like, yes, as Brian said, there will be transport components, and we'll love to hear from people knowledgeable. We'll send emails to lists about the mailing list.
Hi, Colin Perkins, also in the needs transport eyeballs loops, if it continues.
Yeah, Loops was a transport buff, so I hope you all guys went there and gave feedback. Okay, that gets us to my point where I really need some feedback from you guys. So we do have a couple of efforts where something happens with multipass, and it seems that it's getting more. So there's, of course, MPTCP. However, they are basically at the end of their charter. They don't really have a new work item right now. There are people interested in MPTCP in general, but it doesn't look like they have any standardization work to do. So my big question is, should I close the working group, or is there another option? But we also have had a lot of discussion about making Quick multipath capable. It's even in the charter. It will not be in version 1 of Quick, but it will come up again. And there has been a proposal for multipath DCCP in TC working group. And of course, there are other discussions which are related to multipath in PANRG and ICCRG. Yeah, so the important point here that I want to make sure that people are somehow in sync, that everybody knows what the other people are doing, that good thoughts are brought to the different groups and not only discussed in one part of the community. And that also maybe, you know, we don't do the work twice. We solve the problems once and then can apply it somewhere if applicable. And the other problem I really would like to address is that also new people from outside, because these protocols become more mature, so more people get interested in it, that they know where to go, that they have a place to ask their questions, that they know there is a place where this discussion will happen in the IETF, and it's like as easy for them as possible to find the right place. And I have one more quick slide, which is basically kind of the questions a little bit broken down. So do we need a new group in the IETF? Do we need a new group in the IRTF? What to do about MPTCP? What to do about multipath? Quick, is it useful to split the work in some way, or should we make sure it all stays kind of in the same place?
David Black, one of the chairs of TSVWG, and hence with a not quite enlightened self-interest in moving work elsewhere. I would really like to see one forum for multipath topics. That would make an enormous amount of sense. Could I suggest a non-working group BOF for Singapore to go over all of these, possibly along the line, and you might even think of it in along the lines of the dispatch mechanism we see used in other areas. But at least for Singapore, a multipath interest BOF might be a good way to get everybody in one place and have better discussion.
So, quick question. The BOF would make a lot of sense if it's a cross-area topic. Do you see that this is coming up a lot outside of the transport area?
Not sure. Probably don't have enough visibility.
Hi, Lars Eggert. Could you go back? You had a slide that had all the options on it. So I have a variety of opinions, and they change a lot. So right now, so I think MPTCP should probably be closed. If there's any sort of maintenance stuff that pops up, you know, you stick it in TSVWG or TCPM would sort of be the natural homes, right? I sort of saw the DCCP multipath proposal. I didn't hear about SETP. Frankly, I don't really care about either of those two. So I don't. So however, unsurprisingly, I care a lot about Quick. So I think actually, so the multipath work, the main one, right, that we're going to do is for Quick, and in my mind at least, that needs to be done in Quick because it ties in a lot with the protocol details, right? And with TCPM and multipath TCP was already a quite established protocol, one could say, by the time we did multipath TCP, and so there wasn't. I think it was okay to have it as in a different working group, but doing multipath Quick in a working group that isn't the Quick working group, I think will be very difficult. I would rather just give Quick, a third slot or something like that, or maybe we keep the second one and we use it for this. We absolutely want to learn from what multipath TCP did. We don't want to reinvent the stuff. There's a lot of the problem I see is that there's a lot of sort of architectural thinking that was done like already before the IETF work started in Trilogy and elsewhere, right? And so it would probably be good to figure out what the principles are that underlie multipath TCP and apply those to Quick. The protocol mechanisms in multipath TCP are but ugly because they had to be because it was TCP and we needed to get through the middle boxes, right? And so in Quick we can hopefully do this a lot cleaner and simpler. But those principles I think would be valuable to figure out what they were if I could only remember and see how we can apply them. So that could be something that ICCRG could do, or we could have a joint session or a workshop or something. I don't know if it's above.
So in theory, I would like to do it exactly that way. I think that's the right way. However, in practice, what we have right now is that we already have, for example, the problem that some of the, let's say, core TCP people don't show up in MPTCP anymore. And we have the problem that some of the core TCP people don't show up in Quick anymore. So we really have to make sure that the right people show up at the right places. And I'm not sure if that's the perfect solution for it.
But very quickly before I get out of line. So I think that's sort of an artifact of how the things evolved, right? So multipath TCP for a long time has been a proxy protocol, right? And not really a TCP protocol. And so it's not sort of really surprising that the TCP folks aren't there anymore. And I think you would probably, and Quick, right? We don't really have a lot of participation from TCP congestion control recovery people because we really haven't done much. We just like where the bits go and got the underlying protocol correct. I think now this will probably ramp up, especially with Jana's and Martin's work on the simulator and the QLog stuff that we're going to see, where you can actually do congestion control work with Quick, because we actually have a protocol now that runs. So I'm hoping that'll sort of correct itself, but maybe I'm optimistic.
Spencer Dawkins. Maria, thank you for bringing this topic forward to the transport area. It seems like to me that if, to the extent that we can come up with principles that anybody, because I mean, like the point was not to do Quick, right? The point was to be able to do Quick and prove that that now we can do new transport protocols, which might even be different versions of Quick that behave in different ways. So I think that trying to think about things at the principle, what are the principles level, is really worth doing, and then you can figure out where to put the, it seems like to me that like questions like how do you pick which paths to use for which packets when, that maybe that's not tied to a protocol. So that maybe there are things like that you can spin off. If you're asking about cross area possibilities, we've had conversations in the IETF over a long period of time about applications that pop up and want to manage their managed paths themselves. So they might be able to learn from those principles as well, even though they're not transport protocols. I would hope that security and operations people would be curious about some of this as well. But like I say, the big thing was to say thank you for bringing this forward.
Stu Card, Critical Technologies. One other place where multipath work is already being done is the Network Coding Research Group. And so I've actually been
interrupt you saying, is that connected to Quick as well somehow, or is it completely independent?
Independent.
Okay.
So I've actually been running multipath routing and transport to aircraft for at least 15 years. Published a paper back in 2004 at the IEEE Military Communications Conference. So practical background in it, but not a lot published. Just going to first principles, I mean, it's the job of routing to concatenate links to create paths. It's the job of transport to then use the paths with which it's presented. But then if we want to do better than that, it might also be the job of transport to give routing a hint about the kind of paths that it might like. And it might be the job of routing to give transport a hint as to the kinds of paths that it was able to construct. So I think this is intrinsically a cross-layer topic. And it's not just that we need the different people to talk to each other. It's that we need the different protocols to talk to each other. We need ways of layer 3 giving layer 4 hints and layer 4 giving layer 3 hints. And I don't know where within IETF is the right place to talk about these cross-layer hints.
The person with the pin you had standing right behind you and raising his hand.
Hi, Brian Trammell, co-chair of Panergy. So I saw Panergy on the list there as like sort of like problems and requirements. We are actually kind of a venue for problems and requirements and whatnot for a subset of the multipath problem, which is exactly the subset of the multipath problem where you are doing exactly the kind of hinting that Stu was talking about, right? Like so. From what I've heard in the line so far, I had a slightly different opinion when I got in line. The hat is actually kind of messing with my brain. It sounds like a multi-path interest BOF is probably a good idea for Singapore. One of the outcomes of that could be, hey, look, it's the usual suspects in the room. We need to have, I think if you call it a multi-path interest BOF, you're going to get a lot of routing people showing up, and that's a good thing. Just to make sure that when we're talking about the principles, that we're talking about the principles in a sane way. As to where the work ends up after that, it's definitely in the transport area somehow, but I don't want to have the BOF that we haven't had yet in the mic line right here. A reflection on sort of the difference between MPTCP and MP Quick, as I'll say it a little bit less pejoratively than Lars did. The way that TCP was multipath was constrained by the design of TCP in a way that the way that Quick will be multipath is not necessarily constrained by the design of Quick. Right, it's the network. Okay, yeah, so Lars just said it's the network that constrained. Which, yeah, I agree with that. Quick does not have the same set of constraints, right? Quick has a much larger design space that it can explore for how it does multipath. And that itself suggests to me that there does need to be some work separate from Quick on sort of design principles and like transport independent design principles. I think that's a work that we have to take on. I have no idea where to do it. I'd like to discuss that in a BOF in Singapore.
So given Christian is the next speaker and he's the last one in the mic line, we close the mic line.
I asked whether I can jump in last second to ask a really quick clarification question. So when you say multipath, do you think it is in scope for a transport session to use path diversity that is deeper in the network than the first hop or last hop? So are you talking multi-path or multi-interface? Because multi-path TCP originally tried to do multi-path, but what it actually delivered is mostly multi-interface. And I think for Quick, the interest specifically now is on multi-interface support, right? Just sort of to see if this is what you mean or whether you actually mean multi-path or not sure yet.
So I actually had multi-interface in my mind, but there are also multi-path stuff that's crosses transport, right? So that's coming up as well.
Jana Iyengar. This is, I think that this problem statement is way too broad, which relates to something that Lars just said. First, there's a multi-interface versus multi-path, and I think we understand that, but I think it's important to distinguish those things. MPTCP was right to be chartered as a separate working group because there was a ton of protocol work to be done then. That's primarily what happened. We did not discuss the congestion controller really that much. It was a separate document and it was fine, and you could replace it with whatever you want. That was effectively what the protocol documents said, and I think that's appropriate. Similarly, if we think about Quick as the next thing that we want to think about doing multipath in, I agree completely with Lars. That's where the Quick working group is where that discussion ought to happen, and where that I don't think that we need to charter an MP Quick working group is what I'm trying to say here. There is no requirement for an equivalent of the MPTCP working group. In terms of outside of that, I actually don't know what is left to be done. If all we're talking about here, I mean, if you're talking about doing multipath DCCP and SCTP, again, this is all protocol level work that we're talking about, not congestion control work or anything like that. I don't think it makes sense to have them in a common place just because they have the word multipath in front of them, because the work that you're ultimately doing there is protocol work. You want the protocol experts to be in that room. So you want the Quick experts to be in the room where MP Quick is happening. You want TCP experts in the room where MPTCP is happening.
So I don't disagree. But I think there are things left that like may come up in future more when people use these protocols even more, which is like, for example, congestion control. There's questions about scheduling, smaller optimizations, interface questions, which paths to set up when, right, or if at all. And these questions are all very similar. Some of them might clearly be more in the research area than in the transfer protocol. But then, as you're standing there, do you think it would be space for another multipass research group in the IETF? Because that's also my problem. It's also covered by other groups a little bit.
I mean, there's room if you create room for it. You let us Colin. That's not my place to say anything there, right? But I don't know how that there's overlaps here. So in terms of the congestion controller, that could go into ICCRG. The scheduling itself, I would not touch it with a 10-foot pole, because I've done work on that aspect of it, and it's difficult to nail down any particular. You won't come to consensus on anything that's meaningful there. It's ultimately going to be left to implementers to do what they do in terms of scheduling. It might be valuable research, but that's not going to be valuable enough to create a research group for.
So, but actually, that's the right point to relay a comment from Robert Marx from the Jabba. He said, like, the MP Quick authors of the proposed MP Quick multipass, MP Quick draft, they are the same authors as for MPTCP, right? And so the problems I have here, and I tried to phrase down on the slide, was that I want to make sure that those people who have the expertise, even so if they've been working on a different protocol, actually come to the new working group where this work is done. And currently I see that this is not happening, because we have too many places where we do the work. Even so, it's different protocols, and they need to we have places for them. The problem is we have too many places. And the same base problem is for the second point on this slide, where people who are interested in MPTCP, and as soon as I close the MPTC working group, they will think outside of the IETF. They will think we don't have a place for it anymore. So I want to make sure that they can kind of look at the agenda and know where to go and know where to talk to these people, because everybody is still around and open to talk to, right? So that's the problems I have.
Yeah, so I can speak to in terms of MPTCP work, where that should happen. I have a very quick opinion, which is, I think, TCPM or TSVWG, both are wonderful homes for continuing work. That's what we've done in the past. SCTP, when it closed, it moved to TSVWG, and that seemed natural. And here we have two potential homes, and they both seem natural. But in terms of the how to get the right people in the room, we've struggled with that in Quick as well. The loss recovery document, I've tried to bring it up to TCPM and present it. I've done it several times, but we have a few people engaging. Gauri's there, and Bob is involved a bit. But then there's the force of TCPM is not there, right? We have a handful of people who are involved in TCPM who are there, but we're not getting reviews from a lot of other people in TCPM. I don't know how to solve that problem besides encouraging people to show up. If they're interested, they ought to show up and they ought to engage.
So, I mean, even, for example, in Quick, right, you have the same problem, but you could have split up the Quick working group into a quick mapping working group and a Quick core protocol working group, which could have addressed this problem, but maybe caused other problem, whatever. So,
Quick mapping in terms of the
Quick map, HTTP mapping. So this could have addressed the problem we have right now. I don't want to change it. I'm not proposing it, right?
Don't.
But this is what I'm talking about, because making decision about where to do the work and how to frame it is actually gold for getting the right people in the room.
Yeah, in the multipath case, I honestly think that the protocol work is much more than anything that you do above it. I don't think there's a lot of abstraction work to be done. Like you said, the scheduling and the congestion controllers are independent. The congestion controller can go to ICCRG. I don't think we'll do anything useful with just the scheduling. That leaves the protocol work, and that should belong in the protocol homes.
Florin Babescu, Broadcom. A few questions. Besides agreeing with Lars and the previous speaker, I believe that actually having both, it's a bad idea. And why I say so, it's totally dependent on what is your overall timeline that you would like to address this work. If you do consider this work to be used also inside of other SDOs, essentially both would eliminate this work from FreeGPP, at least for the release 17, because practically you cannot do in FreeGPP any work before at least March next year. So forget about having any type of multipath quick. It was already lost in release 16. Other groups like BBF also wanted to have such a work being done. Again, I'm not going to be done. So I don't know what you want to achieve.
I have to disappoint you here. Anyway, I don't think that no matter what we do, there will be no MP quick work before next March.
No, it's not to be. you'll not even be able to start any work. That's the problem.
You can start work, right? People started working on it already.
So again,
but we will not have an official home for it before
as a
next March.
participant and one of the companies which originally proposed this part, you're simply not going to be able to propose any work, even if the work can continue in the next year. Just my feel.
Hi, Colin Perkins speaking as an individual. Just in response to that, I don't think if we have a BOF to discuss this sort of thing, it's going to make the slightest bit of difference to the timescale of the quick work. Anything to do with multipath quick as protocol specifics clearly has to go to the quick working group. I will let Lars chip in for the timescale of the quick working group, but I would be surprised if everything is finished and ready to do multipath work in that time frame.
Let me relay this to the mic. Don't open issues in quick anymore.
That's it. Close all the issues. Close all the issues. In terms of the multipath congestion control work, I mean, yes, obviously we can move. We could do that sort of work in ICCRG. I mean, and in many ways that would make a lot of sense. We could also, potentially, there's been some discussion of potentially moving single path congestion control up into ICCRG rather than trying to do it in a TCP specific way and a quick specific way, for example. And there are potential advantages to doing that. There's also a potential disadvantage, which is that it ends up in the IETF, which means that everything is done as an experimental protocol or as an informational document and not a standards document. And maybe that doesn't matter, and maybe the IETF is okay with referring to informational or experimental documents for the congestion control, and doesn't worry about having standards track congestion control algorithms. But it's certainly something that we should consider.
I mean, there's one more difference. Like IETF documents have IETF consensus, and IRTF documents don't.
Yes. So I mean, it changes the type of review. It changes the type of document we get, and maybe that matters. Maybe that doesn't matter given this particular problem domain. It's not like a lot of the internet runs on standard congestion control anyway, so maybe that doesn't matter. Can we generalize congestion control, multipath congestion control across the transport protocols, or are the protocol-specific differences enough to cause problems? And I'm not sure we've investigated that well enough to know the answer. Maybe we can. I don't know. Similarly, things like path awareness, routing, FEC, retransmission, scheduling. I think we perhaps need a conversation to figure out how general this can be and how much it is unavoidably protocol specific. If we're trying to generalize things, we should understand whether it's possible to generalize them. So I think that's kind of a long-winded way of saying +1 to a longer discussion in Singapore.
David Skenazy, Google. Wow, I really have to eat this one. David Skenazy, Google. This sounds to me a lot like a premature optimization in the sense that the reason we form working groups in the IETF is that we have people that don't have a home. And so we take those birds of a feather and we help them flock together to make a BOF working group so everyone is happy and sings Kumbaya. But but in this case, like, I don't see anyone with a draft saying, I don't know where to put this. Like, if people are doing this work, it'll go to the right place. Say, quick multipath will go in quick, so on and so forth.
You got the part where I said I would close MPTCP, right?
Yeah. And I am not, and the reason we close MPTCP is that there is no more things happening. And if they come back, we will reopen the working group. That's a common pattern at the IETF. You don't need a place for these hypothetical drafts that might come one day.
I again agree, but it doesn't address the problems I have. It doesn't address that people with the expertise we need have to go to multiple groups and potentially have to say the same things over there, right? And it doesn't address the problem that people who come from the outside don't know where to go because they don't know the inner structure as well as we do.
So I understand the theoretical problem you describe. I have never seen it in practice. I don't see these multiple working groups that aren't talking to each other. Like
So we
in this
have
case,
we have it in practice. We have it in MP-TCP because no TCP people show up anymore, and we have it in Quick because the transport people don't show up
but
anymore.
creating a new working group will not get people to show up. Like I work on Quick, and I will keep going to Quick, and if we do multipath in Quick, I will go there. If I don't go to MP-TCP, I won't go to this other working group either. Like at the end of the day, or maybe I will choose to, depending on the drafts there are, but I will go for the drafts in the agenda, not for the working group.
So, but you would go to a working group that is chartered to do MP Quick work, right? Because you want to do that. And if that's happened to be the same working group that works on some kind of TCP extension, I'm not proposing that I want this group, right? But then you would go there.
Yeah, and then leave halfway through. But and people do that a lot. I've done, like, for example, I started this particular meeting in another session because I wanted to see that, and then came over here. We're all busy, there are conflicts, and that will always be the case. If you want cross-pollination, and it's been said before, you want to encourage people to review, and that's very hard. But adding process and working groups is not how you solve this. I don't know how to solve it, but I don't think this will help.
Christian Wiedemer. I'll be brief because I want to leave time for the next speaker.
You got it.
But basically, I mean, what Lars said, I mean, there is no evidence that the guys who are doing multipass are not participating in Quick. They are. So there is no problem to solve there. There is something that could be said about having ICCRG look at the issue of multi-link congestion control from a theoretical point of view. That will be very interesting because that's the kind of stuff that gets picked up. I mean, if I look at the work that Quick did on congestion that various teams do, yeah, in theory they do Reno, but in practice they don't. In practice, they pick the research that has been happening and they put it in their code. So having that in ICCRG would be very nice, yes.
Okay, thank you very much for the input. It might be, but we just go on as we are. But I also heard people who would be interested in a. I said this already. That yes, I sneaked it in. I heard also people who thought that like having a broader communication discussion would be useful. However, I think the community needs to propose something here. So if you're actually interested in this and you can scope it in a way that you think it will be a useful discussion, then please work on that. And now, Christian, you need slides, right?
Yeah. Yeah. If you hit back, should go to the. Yeah, it's slow. It's working. Present.
Okay. Good afternoon. So, a couple of months ago, I wrote a little piece about congestion control and specifically about congestion control and the new transport protocol that are developed in the application space. Speaking about congestion control,
but it doesn't work at all. It doesn't work at all.
Take the PDF.
I wasn't present.
Okay.
No, it was.
That's good.
What? Who
That's
did,
good.
did it know?
So,
okay.
Basically, the point is the following. In the way we have been doing transport pretty much until the last 2-3 years was that if you wanted, transport was thought of as TCP and friends and was developed mostly in the kernel. I mean, yes, there were examples of protocol developed in application space. I mean, BitTorrent comes to mind, but they were kind of specialized. I mean, it was not the general practice. And so the result of that is that if you want to change, say, the TCP retransmission algorithm, well, you have to be that tall to participate. I mean, metaphorically, nothing will actually measure your size. But the idea is that if you want to check in something, say, in the Windows kernel that I know well, then there will be quite a process before you do that. And similarly, if you want to check in something in Linux, you can definitely check that in your own branch and do your own copy. But if you want to have that in the main distribution, there'll be some process. I mean, people will check, what have you been doing? Show me the RFC where that new algorithm is defined. Oh, there is no RFC. Then I want to see your simulation. I want to see something. I want to get face on what you're doing. So there is effectively a gatekeeper that stands between you and imposes friction that limits the amount of crazy innovation that you could do. And the good thing is that application level transport solve that. I mean, if you look at the quick interop spreadsheet, you see 19 implementation. They work on about 4 kernels. So clearly there is independence. And they can do that because the way you ship transport is with the implementation. It's as a library. So you do application update. And for example, if the Google guys want to update the transport running in Chrome shipping on Windows 10, they don't have to ask permission to Microsoft. They don't have to wait that Microsoft implements TCP fast open. They don't do that. They just update that code and they ship it. It's there. And Google is an example, but you could see any kind of application. If you have an app and it speaks to a server and you can update at the same time the server and the code in your app, you're good to go. You can do what you want. So this guy here, the gatekeeper, has been removed. Okay? So, yeah.
Jana Iyengar, do you want me to disagree with you now or should I wait until later?
Jana, I want you to agree with me.
No, I not generally, but there are a couple of points. But I can wait until later if you'd rather. If you would rather that I wait. Okay, later.
So I would say that being able to do that kind of innovation is actually very good. I mean, there's no question about that. And in fact, what we have done by going into, letting people do this transport at the application level is open new opportunities for development and research. And it's not like there is no need for that. I mean, we were mentioning multipass before, but all the problem of migration, estimating which link you go to, how you mix real-time traffic in a non-real-time transport, how you deal with loss independently of congestion, how do you deal with the fading of radio links, etc., etc. All these are problems that are partially solved in the transport that we have. But in fact, there's work to do, okay? And because we have this application level transport, if you are running a research lab, for example, you can tell to your grad students that, hey, take that and try. And they don't have to recompile the kernel, they just have to recompile the app. They can try 25 variations of the algorithms in a single afternoon. So that's great, okay? And I'm sure that because we have done that, we are going to see many more theses, PhD, master, whichever, being written, being worked on. And Lars was telling me that's actually starting to happen. So that's very good. So do not ever quote me in saying that I think it's a bad idea. It's a really good idea. Next. But there is this guy. Okay? And assume that you are working not in a research lab, you are working for some kind of commercial company, and you are developing a new version of the transport that's going to go between your application and your server. And what is this guy going to tell you? It's going to tell you, do you beat Google? Do you beat Facebook? No? Back to work. It's absolutely going to tell you something like that. Or some variation of that. Okay? And that could go very wrong very quickly. I mean, the first way that can go wrong is competitive congestion control. So we know that. We have seen that already. Remember the time where browsers were competing on how many TCP connections they could open at the same time so that they could have n times the congestion window. I mean, if you have application level transport, that's much easier. You just have to change a constant in the code to get the same effect. Already you can see people, I mean, that was actually in the Google Quick code. There is a factor in the Google Quick code that says how many cubic connections do you want to emulate? And you can compile with that factor and you say, the default was 2, I believe, but you could set it to 4 or 16 if you wanted. Okay? And someone is going to invent a super fast version of the new TCP that is not bothered by these stupid losses in the network and goes as fast as you can. I mean, they'll do that. I think they already did, actually, but yes, okay. But now they can put that in their app and ship it. And that's just the competitive congestion control. That's not the most interesting. Suppose that you are managing your bottleneck and you do some smart sensing. We can do that and says, damn, I'm competing with a cubic connection. And they are busting my delay-based congestion control. What can I do? Well, I know the specifics of cubic. I know what I can do. I can do a spike of traffic very briefly. Then I go on doing what I was doing before. I know the spike of traffic will have caused a loss in the cubic in the bottleneck, and the cubic connection is going to back off. And now I can have the network for myself. Okay? And BBR does something like that, actually. But and now, what BBR does to cubic, you can absolutely do to BBR. You look at their technique and how they are doing, you know that they will be sensing at one specific point in the flow. At that precise point, you send a spike. They're going to back off. And they're going to back off for 6 transmission windows. That's great. For the next 6 transmission windows, you get the network for you. And that's what I call adversarial congestion control. And I think that's a new area of research in which we can find many PhDs. Okay, so that's going to happen. I mean, because you don't have any gatekeeper to tell them don't do that. And the only gatekeepers are the network guys. Okay, so, you know, if you give brilliant new guys new tools, stuff may very well happen. And Goethe's poem is an explanation of that. But basically, if you have an application that keep winning local congestion control because they are doing one of those smart adversarial congestion control stuff, what will happen is that the users of the other apps are going to be pissed off because their application doesn't work. And they are going to call the support lines. Not very good. If you are going to have one of those competitive things that emulates 256 connections, it will have some kind of an effect on the network bottleneck between 2 networks, etc., etc. Now, normally, I don't expect that to have more than local effects, but with a little luck and a good software update, who knows? Okay, we have seen software updates already bringing down big companies. So it can very well happen. At that point, you want to call back the master sorcerer, but it's not there anymore. So, hey, and that, I have the next slide. So, who has seen a streetcar named Desire? Yeah, and so that's this lady Blanche Dubois. She's at the end. It says, "I always depended on the kindness of strangers." It's kind of what we do in the network. We kind of depend on the kindness of the transport level developers. And I think that you should not be doing that anymore. We should start from the principle that one way or another, the end-to-end developers are going to fuck off because their interests are not aligned with ours. And if you're a network manager, you have to believe that actually defending against this kind of stuff like competitive congestion control or adversarial congestion control is something you want to have in your network. And that's really my call. My call is, guys, it's time to think about that and start implementing the defense. And when I say in depth, they have to be implemented probably at the access point in the network, but probably at other points that are sensitive as well. So that's the point. Jenna, now I'm sure you agree with me.
After all that, thank you, Christian. Jenna Iyengar. I think this is a very important question. I think it's an important question because we are, as you point out, going into sort of a new space where we are going to have potentially an ease of development and deployment of congestion controllers, and that's going to change things somewhat. It's not clear to me how much. So let me be specific here. You might remember that about, I want to say almost 15 to 20 years ago, video applications started to get deployed on the internet, and they were deploying their own congestion controllers in application space.
Yes.
And again, people were crying murder at that time. And we seem to have survived that. I'm not saying that that necessarily means that we will survive this, but I do want to just remind people that this is not the first time we are sort of seeing this problem where we are concerned that people might start building random stuff and it'll break everything that we love. The thing I wanted to disagree with you at the beginning was you pointed out that there's a gatekeeper, and I agree with you that there has been a bit of a gatekeeper in the Linux kernel, but for most server providers, when you're talking about congestion control for the most part on the internet, we're talking about content providers like Google, cloud providers, etc., etc. Not having something in the kernel has not stopped them from deploying whatever they want to deploy. So not having something upstreamed into Linux has not stopped them from experimenting and deploying. BB has a great example. If you look at Akamai deploys fast. There's a whole bunch of congestion controllers that have been deployed at server farms and server deployments that aren't basically in upstream Linux as it is. And there are measurements, there are various things that are done there. And I guess what I want to say is that the kernel has not been in the past the gatekeeper of this particular thing. It has been people who deploy stuff. So yes, is Google a gatekeeper of this? Absolutely it is. It's a gatekeeper of what they deploy on their servers. Is Netflix a gatekeeper of this? Yes, they are, because they control what they deploy on their servers. And it's not typically what's in stock FreeBSD or stock Linux. So I think that the gatekeepers are different. And in that sense, those gatekeepers have not changed fundamentally.
They have. They have. Take the Google Cloud. Now, the guy who can change the congestion control is not the runner of the Google Cloud. It's every single app that's running in a VM somewhere.
Again, that's not very different. They can already do that with TCP, is my point. They have root privileges on the thing that they run, and they can absolutely change the controller there. They can deploy whatever they want.
In fact, yeah, sure. That's true.
And
should we panic? We can panic slowly.
I will add very quick 2 points because there is a long line behind me, and I'm aware of that.
Yeah. So the line is closed for now. So Brian was lost in.
So what I'm trying to point out here is that thinking about the kernel as a gatekeeper, I think, is a fallacy, because the people who were gatekeeping at the kernel were not and are not experts in congestion control. This is a long-standing problem. And the second thing is, what you're talking about here with isolation of users and so on, I agree with you. That's a useful strategy for doing things. It's already happened a fair bit.
Yes.
It's already happened.
Yes. It's a good thing. Yes.
Last second. So first, worrying about these things makes you an excellent candidate for transport AD. Please. So, no, wait. This is really, you know what? This is really
next question.
You know, it's you know, thumbs up. So I used to worry about many of those same things, and I've sort of chilled out a lot. And there's some reason for it, right? So one reason is, right, so there's sort of roughly two kinds of applications on the internet, right? There's the ones that ship enough bytes to really do some damage, and then there's the ones that don't, right? So the long tail. What the long tail does, who cares, right? Because they don't just have enough data to actually do any damage, really. They might sort of cause some self-interference problem for a particular user that runs that app, and then they get annoyed, but the internet is not at harm from those guys. And then there's like the guys who ship a lot of data, right? But those, funnily enough, are also the people who quite carefully monitor what happens to their traffic, because, you know, their revenue stream pretty directly depends on that really working well and not causing the customers trouble. And that feedback loop is I think, what is actually now the protection that we have for the most part. And then I want to go back to what Jana said, that we do actually see over the last 10, 20 years that access networks, sort of isolate users to an upstream link, so you can at best sort of harm yourself. Yeah. And we saw that when BitTorrent went to Ledbat, right? Because the web calls would die if somebody turned on BitTorrent, and that was not good, and then they fixed it. It was all self-interference. The network wasn't really in danger here, other than, you know, traffic using peering links that it wasn't going over before. That's a separate story. So that's sort of, it's the self-interference is a problem, but the internet is not really at a danger here. But transport ID, Christian Hüttemann, 2020.
I'm a retiree. Come on.
That means you have time. I want to second a lot of those things. I've actually thought about this problem on and off for 2 decades. And Matt Mathis, I'm sorry. There are a bunch of different mechanisms that defend the internet, and up until fairly recently, the recovery code in TCP wasn't good enough, and if you pushed harder on congestion control, you took more losses and therefore ran slower. And so there was this built-in mechanism. Yeah. The recovery code has gotten good enough in the new stacks and several protocols where this is no longer true, and it's, yeah, I know. I thought about that too. Where I have actually run some TCP implementations under situations where they were sustaining above 50% loss because CWind was pegged at some large number, and they just ran happily along, fixing all the holes. You can do this. But there are other things. There's these topological constraints. Access links are a small fraction of the core. If the person you hurt most is the person in the next office, and they're likely to come knock on your door, and there's a whole bunch of mechanisms like that that tend to defend the internet. The things that worried me, I'll be perfectly honest, I am not on the BBR project. And I fretted about BBR1 and some of the situations where it could get in trouble in the public internet. And the telemetry that we had, that the BBR team was looking at very, very carefully, is whether or not running BBR in parallel everywhere globally, the BBR flows had lower round trip times, which meant lower queue occupancy. And so there was a single metric that we were looking at that actually gave us confidence that we weren't hurting the internet anywhere. We don't really have a way of observing that data. And so, but it was a big concern, but people were paying attention to it very much. I think I'll stop there.
Yeah, no, But I agree that people who are shipping large applications, etc., do pay attention, and they are not on the business of cracking the internet.
You can imagine pathologies where a widely deployed game has got bad congestion control in it, and it's not until you get hit 1 million users that you discover that it's an implicit DDoS. Oh, that was the other thing I didn't mention. The common case is actually deliberate DDoS, and they don't care what you think.
Ronnie Evan, I have experience with video conferencing where RTP is a similar thing because it's a transport that runs in the application layer. Now, in that case, in the beginning, even, I mean, you're talking about congestion control. There was no congestion control at all because everybody tried to use as much as they can, and they had the mechanism inside to get over packet loss at up to a certain percentage. So they didn't care much, and they said maybe the other one will reduce the rate, and I'll be able to show that my product worked better. Okay? Yeah. So I think it's a very important problem. By the way, this happened mostly in the SIP environment because in H323 there was a gatekeeper. Yes. Because before you can start a call, you had to ask for bandwidth from someone. It was not enforced, but at least there was the process and the application tried to abide for it. But the moment you leave it open to them to decide whatever they want, they can do whatever they want. They wouldn't ask you what to do. They wouldn't, if they wouldn't care for what the network is about and they can get over losses, then why should they care at all? So I think it's important to have some enforcement for that thing, and maybe to have some proactive congestion control instead of the way we are, that to just give them, oh, we are losing, you may lose packets, so do something about it.
Hello. Victor Vasiliev. So few thoughts. First, many of you might remember, I think about a decade ago, BitTorrent decided that they no longer want to use UDP, and media, including, I think, major press, raised panic about BitTorrent switching to the super aggressive congestion algorithm called LEDBAT. And this is basically this is kind of reminds me because out of all congestion control algorithms I've seen deployed in practice or even published within last 10 years, all of them field buffers much less than Cubic does in worst case and in average case. And this includes BBR-V1, as I said, when almost every iteration of BBR-V1, including the one with horrible bugs where congestion control ran afoul, still had a median RTT better than a Cubic. The second thought is I don't believe those gatekeepers ever existed, and I think a lot of people already mentioned that, one, if you look at the congestion control algorithms in Linux kernel, there's a lot of them, and I'm not sure all of them are rigorously tested. And I mean, even those are rigorously tested. Like TCP Cubic had an awful bug which just made it in certain traffic just like basically simulates slow start like semantics in certain conditions. And that bug existed for like 10 years. And we only found it when we found similar bug in Quick Cubic. So I believe that the level of gatekeeping is overstated, and fundamentally sockets with IP-Proto UDP existed for over 40 years, and the internet has not collapsed. So that's basically my thoughts, but I do agree that if we deploy AQM more widely, this will be better, not because of I'm afraid of collapse, but because this would mean people would be able to run congestion control algorithms that are more robust to stochastic loss, which is not induced by themselves. And that was one of the problems that BBR tried to address, especially in version 1.
And I think that's a very important point. I mean, that's a point I should have made, is that the other big reason of deploying isolation between users is that basically it enables freedom of innovation for those users. And That's kind of the flip side of the story. But if you know that you are safe, then you can try what is the best for you. You don't have to be compatible with Cubic.
Yeah, the thing about BBR versus Cubic competition is that I'm not sure how well understood it is, but it's extremely parametric. As you scale your TCP buffer from like half BGP to 10 BGP, you will see why either one or other dramatically just suppress others' traffic. And that was a big problem with BBR v1, but it worked kind of fine because most buffers were kind of in the middle. And BBR v2 has a lot of heuristics to make this work even better.
So we have to speed a little bit up, so if you don't state anything that was stated already, that would be helpful.
Andrew McGregor, currently at Fastly, but formerly an SRE at Google. SREing a system that did everything on that slide. And it's well documented, well enough documented to serve as a worked example of how you might do this. It's not the only, it's called Bandwidth Enforcer. It's not the only such either. Google has another one. Bandwidth Enforcer is for Google to Google traffic. The other one, which I'm not sure has a public name, but serves the similar purpose for traffic facing the internet. I'd like to point out that traffic out of Google Compute Engine has to run the gauntlet of both of them. And so it's well controlled. I think any responsible CDN or cloud provider is going to have an external facing global omniscient congestion controller of some sort, because otherwise your own mistakes can take out a large fraction of the internet and all your customers with them. It saved Google on the day we accidentally globally deployed BBR to about 80% of the internal traffic. I know I'm not supposed to say that, but you know, I don't work.
And now it's in the minutes.
But we did that, and the cubic traffic didn't stop. And that wasn't all Bandwidth Enforcer. That was also partly just the fact that they turned out to be somewhat more compatible than perhaps, you know, is obviously the case.
Hi, Colin Perkins with No Hats. Ronnie mentioned RTP and video streaming earlier. I'm going to be a little cynical, and I'll probably get fired as chair of the RMCAT working group for saying this, but I don't think RTP congestion control matters. On the basis that by the time you hit persistent congestion, the user has given up because the video is unwatchable anyway. I'm also tempted to say that all the traffic is video anyway. The on-off dynamics of MPEG- completely break congestion control, but it doesn't matter because it's all application limited, and all the large providers have monitoring in place to see if it's causing problems. That said, I don't entirely disagree with you. I think to the extent that this is a problem, it's a worse problem than we think. In that everything is moving to quick, and quick encrypts enough of the transport headers that we have no visibility into whether this is actually a problem or not. Yeah.
You're fired.
Hi. My name is David Skanazi, and I used to be a gatekeeper. So these days I have this laptop, and using it, I can check in code to Google Quick. And as you say, the kids with the Magic Apprentice could break things. Last year on the same time, I had the same laptop that Eric had, which allowed me to check in code to XNU. Kind of the... Actually, now at Google, we have tests, whereas there weren't any. So the gatekeeper is probably better in Google Quick. I mean, I remember a really funny bug where the Apple kernel got into an infinite loop in some cases when you were doing TCP fast open. It just happened that in that infinite loop, there was a call to send a packet out. There was a network in Switzerland that was really unhappy with them for a while. Yeah, so on all your points about how this is getting worse, like I really, really disagree. I saw some people pitch some what I personally think were snake oil companies telling us that hey, look, we make all your traffic faster, where when you look deeper was just a thing that in the kernel disabled congestion control. That was in TCP. That said, while I completely disagree with your premise, I fully support your conclusion. If you want to go around to router manufacturers telling them, the world is about to end, please deploy a QM, continue that. We might be able to solve buffer bloat that way.
Hi, Brian Trammell, not speaking as an employee of Google or as a citizen and internet user in Switzerland. Or actually, as it turns out, a co-author of this slide deck, because I didn't do anything except for remind Christian that he had to do slides, so I have no idea why my name is on it. I'm fine with the name being on it. I agree, actually, that there is a little bit of a problem. I think it's maybe a slightly different problem. I want to go back to something that some other Google guy said. Maybe Matt. I think it was Matt. I think to some extent, the security and reliability here are flip sides of the same thing. They're all essentially transmission safety problems. And the work that has been done to, in some networks, isolate users or isolate processes from each other, or to isolate good traffic from evil DDoS traffic is all kind of the same work. To the extent that putting better AQM in the internet makes that work better, it's a good thing to do on its, anyway. I will say, as a former researcher who spent a fair amount of time trying to get cloud platforms to throw packets at things as fast as I possibly could, all of the ones that I did seem to have some sort of outbound bandwidth policing, and I suspect that almost all of it was there for abuse. So the nice thing about the abuse-riddled internet that we have is that the defenses that we need in order to keep it working minimally well also seem to be pretty good gatekeepers against congestion collapse.
Yeah.
Thanks.
Thank you. Well, thank you for your attention. I accept, the point that we have many more defenses today than people would think, and that's great. I accept that it will be very hard to do something more aggressive to the internet and ship it cubic. We know that. And so that we should not panic, but we should do isolation because it's a good thing. Yeah.
Okay, that was less depressing than I thought. Two more fun parts. We have one more talk. Roman, are you on?
I think so. Can you hear me?
Perfect. Yes, you can start right away.
All right, great. So an update on QLog. Quite quickly, for those who are not into QLog yet, next slide, please. So the main motivation is this: we want to help debug quick implementations. It's difficult to make this kind of visualization and tools just using packet capture files because they don't contain things like congestion control information. So skip the next slide and then go 1 to 2, next slide, the next one. So what we proposed to help that, what will make tooling development much easier if everybody would just output the same type of log, of course. And we proposed what we call QLog. It's a relatively simple scheme based on JSON because we want to make web-based tools, and we want it to be human readable for people not using those tools. And so skip the next slide. And so we presented that at the end of last year, and a bit as a surprise to me, a lot of people seemed quite enthusiastic about that. A lot of people had some interest. Among those was Mirja, and she said, why would you do this just for Quick and HTTP3? Why can't we do this for more than those protocols? And so I got the chance to present some of our thoughts on that last time at IETF in Prague a couple of months ago. Again, a lot of people seemed interested, but it was deemed a bit too early to talk about doing maybe a BOF or a working group. We should get some more experience using Quick as a kind of an incubator to get some more insights. And so that's where we left it off last time, and so we have been doing that since. So next slide, please. What we currently have is 2 different drafts, 2 documents. One that we're calling the high-level schema, which is basically the protocol agnostic, the general purpose part of what we're doing, and then the other draft is the quick specific stuff. The second one is very easy to understand, right? Quick has packets. It has packet numbers. It has stream frames that have lengths and offsets. It's basically us going through the Quick documents and copying over things into a JSON format. It's very long and it's very boring. The left one is a bit more interesting. Next slide. You can see it as kind of the metadata that helps you interpret the events on the right side. So the simplest form is that we have like a title and a description of the current file. But the most important field there is the protocol type. As you can see, if that is the current value is quick HTTP3, that means the events in that part of the file are from the other document. But so if we would expand this to more protocols, next slide, we would change the value of that field, and suddenly you would have, for example, TCP of HTTP2 events, of course. So that's kind of the high-level approach that we're taking now to still have something protocol agnostic while working on a quick specific thing. I'm going to give a little bit more detail on that, just some examples. Next slide. So in the high-level schema, for example, some people were worried about the overhead of JSON. So we have some file size optimizations that you can skip logging the same value in the same file multiple times. We also like to make this very flexible. So for example, we've been working with Facebook. They feel that they have a lot of custom events specific to their implementation. We support that they can also log those without a specific schema. The bottom one is I think one of the most interesting things is that we want to do an end-to-end log. So you have not just client and server, but you also have several in-network intermediaries that you want to log. If you do that with PCAPs, you would probably end up with 4 individual files without much context, and it would be difficult to bundle them together. So one of the things that QLog does is allow you to aggregate different traces into the same QLog file and then provide some context. So for example, here we have the vantage point saying from which point of view was this trace taken. This can also allow us to add different protocols into the same file. For example, let's say you have an HTTP2 and a TCP, an HTTP2 implementation. You would have HTTP2 traces from a user space implementation and then TCP level traces maybe from the kernel. And you could combine them in the same file to nicely keep everything together. Next slide. We have other things that make it, that we really want to keep things in one file. So we talked to, for example, Jana Iyengar from Fastly, and he said, you know, we're probably going to have thousands of QLogs, and we're mostly interested in, for example, the ones that have a high packet loss rate. And so what we have now is like a summary field on top that has some aggregate information for this file. So you can very quickly just sift through all these files without having to download them in full to find the ones that you're looking for. The second thing is, again, with the tools. If you loaded this, you're probably going to zoom in on this particular section. You're going to filter some stuff, or you're going to change the colors. And if you then want to share that with a colleague, you would have to take a screenshot right now, right? So instead of doing that, we say, let's just embed those settings into the QLog file as well. So you can just share the adjusted QLog file with a colleague. They can open it up in the same tool and view the exact same data that you were looking at before. So those are just a couple of examples of what is in the high-level schema. Next slide. In terms of the event definition, we currently have about 40 events. I think it will be about twice that by the end. Some of the most important ones, I think, are of course the ones that are not in the typical packet capture, so the things related to congestion control or when packets were lost, that kind of stuff. But of course, next to that, we also log your typical packet tracing type event. Next slide. So for example, we have, of course, a typical packet received event where you just log the received quick packet with its constituent frames. For example, here there's an ACK frame being logged, and this ACK frame is ACKing packets 4 to 7. Using this, we kind of notice that it's not enough in all use cases. For example, we had this case where we clearly saw the acknowledgement frame coming in, and after that, it was still logging a packet lost for one of the just ACKed packets, right? Which is very weird. That should never happen. And we found out that it was a bug in our implementation where we parse the ACK frames, but we don't immediately process them. So there was kind of a long time in between those two sometimes, and it was time enough for the loss event timer to come in and declare the packet lost, even though the ACK frame just wasn't processed. So the only way to really solve that, next slide, is to add yet another event, a more explicit event specifically for packet acknowledgement, because those receipt of the ACK frame and the package acknowledged might not be directly correlated. So that's one example. I recently did another talk with a lot more information, which you can find in the YouTube link on the bottom of the slide. So as you can see, we've made a lot of progress on the text. I'm happy to say we also made some implementation progress. Next slide. We currently have 5 different quick stacks that are outputting qlog directly. What I forgot to say with last slide is we might end up with 80 plus events, but I do not expect everybody to implement those 80 events. Most people will probably have enough with about 20 of those events. And so a lot of these tools are outputting qlog, but they're definitely not outputting every possible qlog event. They're outputting the main basic set that is supported by our current tools. Those tools are not incredibly extensive right now. We mainly have one that is being used a lot. It's the one you're seeing. It's for debugging congestion control mainly. But we are working very hard on new tools. I'm working full-time on new tools that will come out over the course of August and September, so expect to see a lot of movement in that space. Next slide, please. So the nice thing about having other people look at this is that we've been getting some feedback from other implementers. It seems that for a lot of people, the overhead actually is quite okay. Facebook reports that they're logging 20 billion quick events per day. I don't think they're actually logging qlog events at that scale yet, but it's nice to know that it's possible that it's a possible way forward. Someone mentioned that they would like to use qlog as a way to implement tests. So instead of augmenting the code with unit testing, they can just look at what was happening in the qlog and try to devise if the test failed or succeeded that way, which I think is a very interesting use case. And then the last sentence there was very interesting for me, because when we started this, I asked people, why isn't anybody doing this yet? Why doesn't this exist? And a lot of people said, well, it's a lot of work and we don't really have the manpower. Next slide. So I think qlog really helps take away a bit of that overhead in terms of work. We recently did some work on ACP3 prioritization. So in this, the top visualization, each row is an individual qlog file, one by page load. So each vertical rectangle is one quick packet. And I really like this visualization because it immediately makes clear the differences between different prioritization approaches, right? And yet it only took me about a day to create this visualization based on the qlog formats. So it's a lot of profit for not a lot of work. The bottom one is even faster. This was implemented by one of our bachelor students in about 2 hours and really helped us to debug the prioritization implementation as we were going. So I really like that qlog enables this kind of quick and dirty, fast visualization that helps implement some of the complex systems as well. So we've got a lot of good feedback. We've also got a lot of what I would call constructive feedback. Next slide. So there are also people that say that there is some overhead. I'm a bit ashamed to admit that our own implementation got very slow if we enable all the qlogging, but that's because we're using JavaScript and a very crappy logging framework. But still, there is a cost. Some people still don't like JSON. Some people, their implementations aren't fit to output qlog as we have it right now. And then one of the most important ones is the one at the bottom is, even besides the possible performance overhead, there is also a certain maintenance burden in adding this logging. Now if something changes in Quick, you don't just need to update your business logic, you also need to update your logging code. And so they would rather wait until things settle down a bit. I think that's quite ironic coming from people implementing Quick, right? But it's still a very good point to make. So next slide. We've seen that a lot of stacks that have these reservations right now still are trying to move towards qlog. They mainly do that by using what I'm calling converters. So they have some kind of an internal logging format. They write a small program that transforms that into qlog so that they can use the tools. this works just fine. I think it's a good approach. I think it's a nice way to eventually maybe get the browser output into a QLog compatible form as well, because I don't think they might want to implement QLog directly. But I am a bit worried about the maintenance burden for these converters down the line. So that's about what I had to say. Next slide. Of course, I'm a bit biased, but I'm very happy with what we've been able to do. I'm very happy with where we're going. I'm very happy with all the support from the community. Thank you, everyone. It has been great. However, next slide, there remains some serious open questions. One of the major feedbacks from last time was that we need to think about privacy and security. Sadly, that is one of the areas that has seen the least amount of progress since then. One, because I'm not an expert on that, and two, because we haven't really had a lot of feedback on that. So if you have opinions on that and ways that we can integrate this into the format, please let us know. And then it seems like this is working quite well for Quick, but that doesn't mean that it might work well for other protocols as well. So that's maybe a discussion we still need to have. Next and last slide. So maybe we don't have to have all these discussions right now. We also don't have time. So please join us on GitHub. We also have a brand new QLog mailing list. Thank you for that, Miriam. I'm also planning on launching the quicktools.info website, which is going to gather all the quick tooling that exists, not just ours, but everything that other people have made as well, to work as kind of a central hub. If you want to go further than that, feel free to add QLog, not just to a quick stack. It would be fantastic to have someone try to do this for other protocols as well, if you're able to do that. And of course, we shouldn't be the only ones making open source visualization tools. Feel free to do that as well. Finally, I don't know what people want in terms of next steps. Is it something that should be a working group above or not at all? Please let me know. So thank you.
Thanks a lot. We take a few short questions.
Hi, Robin. Just wanted to say sorry I've not had time to make the Google Quick Tracing compatible with QLog yet. This is something we're working on, but we still have time. I wanted to note about extension from Quick to other protocol. From our very old logging format was designed to be compatible with TCP and Quick, and it didn't make anyone happy, neither TCP nor Quick people. Because it turns out that while protocols are similar on some level, they're also substantially different in many important ways. Just wanted to note that. But this is really exciting work.
Thank you.
Hey, Robin, Jana Iyengar. Thank you so much for your work. This is super, super cool. I'm glad that you put the summary stuff in. You've got a very clackety keyboard. Do you mind?
Yeah, sorry. Stopping notes.
No, it's lovely.
We have a note taker here.
So the main thing I want to say is it's great to see you continuing to do work on this, and I will be soon starting to work on integrating quickly with QLog as well. So I hope to be engaging with you on that soon. In terms of the question of BOF, working group, etc., I honestly think that the work as it's going along is great. I think that there should be just more iterations on how people integrating, and then as people start using traces, which hopefully will happen as people start to do more performance testing, which again we are trying to get the quick implementers to do more performance testing shortly. That there will be evolution at that point. And I think there's organic engagement that's happening right now that is wonderful. I don't think that formalizing this in any other way is necessary at this point, because I'm also not sure what the outcome of such a process would be. But those are my thoughts. I was just going to say, and thanks again, but you should be showing up here.
Well, if you can finance my flight next time, I will.
So yeah, so that's this room has a lot of money. Please, seriously, people who want me step up and see what we can do about Singapore. Robin, thank you very much for this. Thank you for giving the talk at 11 p.m. I'm like, as somebody who like really encouraged you to bring this forward, I'm kind of shocked and amazed at how far this has come in one meeting cycle. This is really, really cool. I will reiterate what Jonna said. Given the amount of progress that's going on sort of on the code and actually the impact that this is having on the quick development and interop effort, I would the next steps are keep on keeping on making it better as a tool set. We'll come back and backfill the how can we generalize this to sort of like transport development logging stuff later. I actually had a question about the privacy and security stuff, but since we're kind of short on time, I will take that offline for you. Again, thank you very much. I'm kind of shocked and appalled at how awesome this is.
Thank you very much, Robin. Unfortunately, we will close this meeting with a sad news. Sally Floyd is in the hospital, and many people in this room knew her very well, I guess. So we will ask you to come to the front and take a picture for her, and we will send it to her as memory. Thank you.
We need some light. That's, I guess, maybe over there. If you need somewhere where there's good light, you might have to go up to the yeah. Yeah, against the wall.